Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. Today we're going to be starting Unit 7, Lesson 1. Don't forget to put your first and last name, period, and the date in the upper right-hand corner of your paper, like always. So even though we're starting Unit 7 today, you will be doing the Unit 6 quiz 2, I believe, on Wednesday for tutorial day. So there will still be a quiz on tutorial day for you to do over the Unit 6 stuff from last week and the week before that. Or the 2 weeks before that, I guess. So we are starting Unit 7, but you will still have a quiz that you have to do over Unit 6. Just a heads up. So our topic today is arithmetic sequences. We're going to be talking about these things called sequences all week. Today we're doing arithmetic sequences. On Thursday and Friday we'll do geometric. So today's objective is I will define, identify, and apply arithmetic sequences. Mastery will be demonstrated by scoring at least 80% on the extra practice. So, what is a sequence? Well, a sequence is an ordered list of numbers. So a sequence is a list of numbers that are put in a specific order, and you cannot write them out of order. So if you look at the example below this, underneath the explicit formula, a sequence of numbers could be like 2, 4, 6, 8, and then those ... dots just mean that it continues on from there. So the order of these numbers matters, and they're in a specific order, which makes them a sequence. So every sequence has a list of ordered terms, and there's always a first term, a second term, a third term, and so on for however long that sequence is. So the way we represent those terms looks like this. Your first term is term A sub 1. The second term is A sub 2. The third term would be A sub 3. Your fourth term would be A sub 4. So on and so forth until you get to your last two terms. And your last term could be A sub n. And then the term before that would be A sub n minus 1. So let me explain how I kind of got those. So this term right here is our second term. So A sub 2, well, 2 minus 1 is 1. So the term before that is A sub 1. This term is A sub 4, our fourth term. The term before that is A sub 3. Well, 4 minus 1 would be 3. So whenever you have term n, the term before that is just n minus 1, because n could be any number of term in that sequence. So n minus 1 just means the term before that. It's kind of a fancy way of saying that. So remember, A sub 1 represented the first term or the initial term. A sub 2 represents the second term. A sub 3 represents the third term. A sub 4 would represent the fourth term. A sub n is the nth term in the sequence. And so we're going to be dealing with different terms in a sequence. N could be 100, so it would be like the 100th term in the sequence. And then A sub n minus 1 is your n minus 1 term, the term before the nth term. All right, now we need to talk about an explicit formula. So an explicit formula describes, I'm going to wait for those bells just a second. So an explicit formula describes the nth term of a sequence using the number n. So for example, we could have a sequence of 2, 4, 6, 8. So if I wanted to describe this sequence using the number n, we're going to have to look at a couple things real quick. So one of the first things we need to look at is the term, the number of the term, and then what that term is. So what n is, and then what that term is, the nth term. So when n is 1, our first term is 2. When n is 2, our second term is 4. When n is 3, our third term is 6, and our fourth term is 8. So That means that 2 is our a sub 1, 4 is our a sub 2, 6 is our a sub 3, and 8 is our a sub 4, so on and so forth. So let's see how these things relate to the number n. Well, isn't 2 times 1? And isn't 4 2 times 2? So if you notice, n is 1. 2 times 1 gets me that a sub 1 term. When n is 2, 2 times that 2 gets me that a sub 2 term. Okay. Now, how do 3 and 6 relate? Well, isn't 2 times 3 6? So my n is 3. I'm multiplying that by 2. And as you can see, each time I'm multiplying my n by 2, and I get the number in that sequence. So that means that we can represent this sequence with the explicit formula that a sub n is equal to 2 times n. So let's see if this works. Let's see what we get for a sub 4. Well, for a sub 4, we would get 2 times 4, and that would be 8. And that matches the next term in our sequence. So then if I asked you to find the 20th term, you would use our formula and you would do 2 times 20, which would be equal to 40. And you can use this explicit formula to find any term in our sequence. All right. So now we're going to find the terms in a sequence using an explicit formula. So for part A, a sequence has an explicit formula of a sub n equals 3 times n minus 2. So we're going to use this formula to find the first 5 terms in the sequence. We're going to use it to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So we're using it to find the first, second, third, fourth, and fifth terms. So what we're going to do is, for a sub 1, remember each term is represented by a sub n. So in this case, our n would be 1. We just plug that in. 3 times n minus 2. So 3 times 1 minus 2 would be 3 minus 2, which is 1. Now let's find the second term. 3 times n, this time it's 2, minus 2 is equal to 6 minus 2, which is 4. Now let's find the third term. 3 times 3 minus 2 is equal to 9 minus 2, which is 7. And we continue going from there. Why don't you go ahead and find the fourth and the fifth terms without me? So the fourth term is 10, the fifth term is 13. All right. A sequence has an explicit formula. A sub n is equal to 12 times n plus 3. What is the 12th term in the sequence? So this is the 12th term. A sub 12 means the 12th term. I'm saying, just to be clear, when I say a sub 12, I'm literally saying a and then the word sub 12. And what that means is subscript. So when you have subscript, you write the thing below where the normal line is. Kind of like, I don't know if you've heard of like superscript. So like when we write an exponent, like when you have x squared and that 2 is tiny in a pi, that's a superscript. If you had x sub 2, you're writing it as a subscript, which is tiny and then lower than the line. Okay, just to be clear on what I'm saying. So I want you to go ahead and find a sub 12 on your own using the given explicit formula. Go ahead and give it a shot. So I got a sub 12, or our 12th term, is 147. All right, we're actually going to skip example 2. We don't have enough time to do this today. All right, so we're going to skip those. And now we're going to talk about a recursive formula. So what we just talked about was an explicit formula. Now we're going to compare that to a recursive formula. So a recursive formula requires two parts. The first part that you have to have in order to write a recursive formula is the value of the first term, or that initial condition. So if you look at this sequence, 133, 130, 127, and 124, and continued from there, our initial condition, or the value of the first term, is 133. So A sub 1 is 133. Then for a recursive formula, you have to relate each term after the first term to the one before it. So as you can see, to get the second term, so to get from 133 to 130, you would subtract 3 from 133. To get to 127 from 130, you would subtract 3. And again, to get to that fourth term, you would subtract 3 from the third term. So we create a recursive formula by relating each term to the previous one. So what that looks like is you take so any term is equal to the term before it minus 3. So you take whatever term was before it and you subtract 3. So let me show you how that works with some examples. We're going to write a recursive formula for this sequence. So to help me figure out how to write the recursive formula for this, what I'm going to do is I'm going to make myself a little table. And the reason I know I'm going to need a recursive formula is because if you check this out, to get from 0 to 3, we would add 3. But then for the next one, we would have to add 4. And then 7 to 12 would be adding 5. And then 12 to 18 would be adding 6. So we don't have like a consistent rate of change here. So I'm going to make a table to help me out. So when I make my table, I'm going to have each term. So my first term is 0. My second term is 3. My third term is 7. And my fourth term is 12. And I'm going to save that fifth term of 18 for later to check and make sure that my formula works. So I'm just going to look at the first 4 terms. So that initial term is 0. Then the second is 3. The third is 7. And the fourth term is 12. So what I notice is to get from 0 to 3, I add 3. To get from 3 to 7, I would add 4. To get from 7 to 12, I would have to add 5. Well, each time I'm going up by 1, right? Well, check this out. If I take 2 and I add 1, I would get 3. If I take 3 and I add 1, I would get 4. If I take 4 and add 1, I would get 5. So what's happening is I'm adding 1 to whatever n is each time. And I add that to the previous term. So my recursive formula is going to look like this. Any term in this series is equal to the previous term plus n plus 1. So you have to use whatever the previous term was, and then you add n plus 1 to it. So let's see if this works for the fifth term, for a sub 5. So the previous term is 12, and I'm going to add n plus 1. Well, my n this time is 5 because it's the fifth term. 5 plus 1 is 6. 6 plus 12 is 18. My fifth term should be 18. And does that match what we had in our sequence? Yes, it does. So we know that this formula works. So to find any term in this series, you take the term before it, then you add n plus 1 to it. Okay. I actually didn't want to circle that. So my final answer is the formula. All right. What about the recursive formula for this one? To figure out this formula, you don't have to do as much work. It's not as tricky. Think about what happens to get from 100 to 10. Well, what could you do to 100 and get 10? Could you add, subtract, multiply, or divide by something? Then could you do that same thing to get from 10 to 1? And how about 1 to 0.1? How would we get from the first term to the next? So we would divide. If I take 100 and I divide by 10, I get 10. If I take 10 and divide by 10, I get 1. If I take 1 and divide by 10, I get 0.1. So on and so forth. So my recursive formula, the next term is equal to the term before it divided by 10. So to find the next term, you just take the term before it and divide by 10. And that's it. All right, so now we need to talk about arithmetic sequences. So arithmetic sequences are a specific type of sequence where you have a common difference. So I'll talk more about what that means in just a second. So the difference between any two consecutive terms is always the same number. So there's always a common difference. So the way I talk about an arithmetic sequence is you're going to have your first term. We'll call that first term A. Then the second term is A plus whatever your common difference is. The third term is A plus 2 of those differences. The third term is A plus 3 of those differences. Sorry, that would be the fourth term. The fifth term is A plus 4 of those differences, and so on and so forth. Okay. So we have two types of arithmetic sequences. When we write our formulas, we can have a recursive formula or an explicit formula. So a recursive formula will always look like this. A sub n will always be equal to the previous term plus the difference. So if you know the previous term, you just add the common difference and then you have the next term. But if you don't know the previous term, then you're going to use an explicit formula. So you're going to use a recursive formula if you know the previous term. If you don't, then you use the explicit formula. So the explicit formula is when you don't know the previous term. And when you use an explicit formula, you're going to use A sub n is equal to the first term, the initial term, plus n minus 1 times the common difference. So let's talk about what some of these letters mean. D is your common difference. So D is the common difference. And A represents your initial term or your first term. A sub 1 is equal to A, which represents your initial or your first term. So the first thing we're going to do in example 4 is we're just going to determine, is the sequence arithmetic? So 3, 6, 9, 12, 15. To get from the first term to the second term, I would add 3. To get from 6 to 9, I would add 3. From 9 to 12, I would add 3. From 12 to 15, I would add 3. So yes, this is an arithmetic sequence because we have a common difference of 3. So yes, it is arithmetic, and we have a common difference of 3. So D would equal 3 in our formula. Okay. Is the following sequence arithmetic? 1, 4, 9, 16, 25. You tell me, is this an arithmetic sequence or not? And how do you know? So this is not an arithmetic sequence because there is no common difference. To get from one term to the next, the difference changes every time. All right. Now we're going to find the 100th term in this arithmetic sequence. So we're only given the first two terms. We're given 6 and 11, and then it continues from there. But we need to be able to find the 100th term. So am I going to use an explicit or a recursive formula? Well, to find the 100th term, in order to use a recursive formula, I would need to know the 99th term, the term before that. I don't know n equals 99. I only know n equals 1 and 2. I have the first term and the second term. So I don't have the 99th and I don't have the 100th. So I'm not going to use a recursive formula. I'm going to use the explicit formula because I don't know the 99th term. So my explicit formula is going to look like a sub n is equal to a, the initial, or the first term, plus n minus 1 times d. So I know that I want to use an explicit formula and it's going to look like a sub n is equal to a plus n minus 1 times d. So n minus 1 times d. Okay, so to find these things that we need, a is your initial term. So a would be equal to, our initial term is 6. N is the term you're looking for. We're looking for the 100th term. So n is 100. Then we need to find d, our common difference. So d would be equal to, so just take the first two terms and subtract them, and we would get 5. So to get from 6 to 11, I would add 5. So d is equal to 5. Now we're going to plug those things in to our equation. So a sub n is equal to 6 plus n minus 1 times 5. Now we're looking for the 100th term, so I'm going to plug in 100 for n, 6 plus 100 minus 1 times 5. So that would be 99 times 5 plus 6, which is 501. So our 100th term would be 501. All right, go ahead and do your extra practice. When you're done, check it over with me, and I'll see you back in class. Have a good day.